Managing a large number of files locally is one thing, but if I need to save files to an external media or transfer them to another system, it can be useful to archive those files or even compress those files. Unlike WinZip or pkzip, Linux separates these two capabilities of archiving and compressing into separate utilities. But like many things in Linux and Unix, multiple commands can call other commands, and they can be strung together. So for example, the most common archiving tool that we use is the tar command, and it has options on it that allow it to call a couple of different compression algorithms, including gzip and bzip2. Let's begin by looking at the tar command and its man page. This is for a specific version of tar. It's a GNU project, so if I go down to the bottom, I may find a See Also section that might refer me over to an info page. Or I might simply also look at info and tar and get a little bit more information on using the tar command. I'm going to stick to a few basic commands, so I'll use those that are specified specifically in the man page. With the tar command, we're going to view the contents, create an archive, or extract an archive. Those are the three major functions of what we will use. With the tar command, we do have to specify one of these types of actions as one of our options. So even though the synopsis at the top has the square brackets around option to indicate that options are optional, we do have to have some type of option. tar stands for tape archive. This utility was originally created to sequentially write multiple files to SCSI tape devices. More commonly, we archive to another file that we can then transfer to removable media or to another system. We'll see that we will specify an F option in order to make that possible. tar is not the only archiving utility. CPIO is another utility that's used to copy files to and from archives. It has slightly different syntax, but similar functionality. It's used by other systems, such as packaging systems, in order to create the sets of files that are used during many installation programs. But most users archive their own files using the tar command. Let's look at some samples of how we use the tar command. I have a few sample tar files created in a samples directory. Each of these ends in .tar, which is the common naming convention that we use. The file command on these files shows me, in fact, that they are seen as a POSIX tar archive, as opposed to an ASCII text file, and so therefore I probably don't want to cat these files. I want to use a tar command in order to view their contents. The tar command is also unusual in that many versions don't require the dash when you specify an option. For example, I can list the table of contents for one of these particular files, samples1, for example, and get a list of the files that are there. The T is to list what I think of as the table of contents of that file. And the F is the option that we use to specify what file or source of the archive. Again, if I leave the F off, the tar command assumes that it's going to look for a SCSI tape device as the source of the archive. For this reason, order does matter. If I try to take this command and put it in a different order, FT, it may or may not work depending on how it recognizes the T is also an option. Some older versions only worked correctly if F was the last option listed and then immediately followed by the actual name of the archive. I can also get more details with the V verbose. So looking at a verbose listing of my table of contents shows size, date, ownership, and permissions for these files that are contained within this archive. Notice also that all I have in this archive is a list of specific files. They're not in a subdirectory. So if I come and look in my current directory, which has some match files already, if I try to take this tar command and use the X for extract of this particular samples1 archive, and look in my current directory, it's merged those files into my current directory. A best practice in this case, after viewing the contents of the file and realizing that there is no subdirectory within the archive, would be to make some sort of a match temp directory, cd into that directory, and then run my command from there. I used a relative path, so I'm going to need to make sure I change my relative path. And now I have only the files that are in the archive instead of also having some of the original match 8 files. I've also not overwritten any files that I might have had in my current directory when I expanded this archive. A common practice when we create an archive is to include a subdirectory. For example, if I look at the table of contents for the samples sample2 archive, if I include the F option correctly, notice that that says lesson 4 and then the various match files. So now I'm in lesson 4, but what's stored in the archive is a relative path. The tar command will create that. If I extract this samples2 archive, I get a lesson 4 subdirectory, and inside of lesson 4 are the match files. So this is a sample where the archive was created with a subdirectory structure so that when I expanded things out, it would create that subdirectory for me. In this case, it's a simple name, but it could have been a little bit more descriptive, such as a program version name, or it could have had a date stamp as part of the name of the directory that I included in my archive. If I want to create a tar archive, I'll use the tar command with the C option for create. The F option is still used to specify where I want to create this. Perhaps I create it in temp directory and I call it homefiles.tar. It will not give it an extension. I need to name it what I want it to be by default here. And then I can tell it what I want to put in there. And for example, I could say home Susan. I could give my home directory for that location. If I wanted to include only a few specific files, I am in my home directory, so I could say lesson 1, actually I could say lesson asterisk and just get the lesson directories. And I have an extra CD in here. I added on to an up arrow. There we go. So I did a tar command, and now I can do a tar tf of this archive that I created. And it has each of the lessons that are there. If I scroll back far enough, I again see that I used my file name generation characters to select all of the subdirectories that I was interested in, being any of those that started with lesson. Again, since I've created the archive with subdirectories, when I do something like change to a temp directory, look at where I am, look at what's available here, and I do a tar xf of my home files, and look again at what I have here, I now have lesson 1, lesson 3, lesson 4, etc. with these directories and their contents, because it's created that directory tree structure in my current directory as I extracted it. Let's look at the size of this file that I created in temp. Notice I did not create it in my current directory so that it did not try to include itself within its archive, even though I narrowed my selections with that. The ls command has an h option as well that makes it a little bit more readable, and I can see what size I have for this particular file. This becomes helpful as I get to larger archives. Let's do the same thing. I'm going to use my Control-R to search through my history for my create command with tar, but this time I'm going to add a Z option. And since I am adding compression, I could say .gz, or a common abbreviation that we use is tgz to mean that it's a tar archive that's been gzipped compressed. This time when I look at the size of that file, and I overwrote it, my gz, I gave it a different name. The new file that's with compression is only 8K. It's a much smaller because I've added compression to it. This is a way that we can combine both archiving and compressing. The Z option on tar is calling a gzip command. Gzip is for compressing and expanding files. It has a corresponding gunzip. You can also use gzip with a -D option to decompress. And there's also a zcat if it's a compressed text file and I want to cat it or look at its contents without having to first uncompress it to a new file, I can use zcat. You can also use gzip with a -C option to do the same thing. So there are multiple ways to accomplish the same tasks. With gzip, let's look at these with a long listing. I could also do this of an existing file. So if I take and use gzip on homefiles.tar and look at it now, gzip itself has added an extension, a .gz. This is its default behavior. And there are options on the gzip command in order to give it a specific file name. So if I had wanted to name it a tgz, I could by specifying other options, output file names. The default is to use the same basic name and add a .gz when I've compressed it. Notice it came down to the same size. Doesn't make any difference whether you archive it and then compress it, or if you archive it as you compress it. If I look at a file command on these, both of them are seen as gzip compressed data. One of them, the .gz, does know that it originated from a .tar file. The other one simply says it comes from Unix because it came from the tar command itself. So a little bit different information, but very similar. If I want to decompress this, gzip -D on home files tar.gz, and it automatically took the extension off for me as well as put it back to its original size. One thing to keep in mind is that gzip is only compressing, whereas tar is doing the archiving. Let's go back to our home directory and my sample files, where I have 3 tar files. If I say gzip on all of these, and I do an ls-lh now, notice that my output is still 3 files. Each individual file was compressed and did become smaller in size, but they were not archived together. If I want to archive them into a single file, I need the tar command. If I want to compress them, I need gzip. And if I want to combine the combination, there are options on the tar command in order to call the gzip command.